We have a requirement here in our in condition slopes that the last segment is going to be a constant 5-foot width at a 2-to-1 slope, and then we're going to have a variable width here on our 1.3-to-1 slope. So this is different than normal in conditions where we construct the first segment and then the last segment goes out and seeks the target surface, and it's variable because it's going out at whatever distance to find the surface. So in this case, we need this last segment to be fixed, and we're going to have our variable length on our slope. So to do that, we're going to start from the point. We're going to do some do not constructs to go find the location of the intersect. Then we're going to come backward from there with some regular constrained components. And just to show where we're going to go with this, as the surface moves up and down, the last segment is fixed at 5 feet, and then the steeper slope is variable. So the way we did that was we have these two in condition points here that I've marked as do not construct. We'll turn those on to look at it. And we'll go pick this one and set it as construction as well. So this is the actual in condition that solves to the terrain. And what we did was we kind of went backward in the construction of the elements. Since we always need this 5-foot segment, we're going out 5 foot at the 2-to-1, and then we're going up and seeking at the 1.3-to-1 and to find the point. Once we find the intersection point with the surface, we add this constrained component here, and this is just a regular constrained component. It's not an in condition, and it just starts at the intersection point. It comes down 5 feet at a 2-to-1, and then goes at the 1.3-to-1 back to the hinge point. And we made this a parent component to this in condition over here. So let's go ahead and construct that over here on the right side so we can see what we're going to do. So I'm going to right click, add new component, and end condition. And going to start at our hinge point here. And then the first point is going to be that fixed width. It's going to be -5 because we're on the left side. And then the slope is going to be -2-to-1, which is 1:2. When I input it here, again, it's minus because it's going down to the right. So we'll place that point. And then from there, we go up, and the distance it's going to be infinitely. So the distance, I'm just going to put 10. And then the slope is going to be the -1:1.3. Okay, so I put that in backward. I can go and change that real quick. There, I need to put that -10 since we're going to the left. And that's our do not construct in condition. That's going to be seeking the surface infinitely. And once we have the location of the intersection, we can come in, add new component, constrained component, and we're going to give that just a grass feature definition. And all we have to do is snap to the location point. We're going to come down that 5 feet. We're going to go to the right, so that is going to be a +5, and then -2-to-1, which I input as 1:2. That gives us our fixed segment there. And then I can really just come down and snap to that hinge point because I know that's at the correct slope, since that's how I built it on the other side there. And then the last thing I need to do is I need to make this constrained component a child of this in condition, so that this component doesn't get placed unless this in condition solves. So I'm going to double click and edit that component, and I'm going to make its parent component this in condition there. And then the last thing I need to do is set these points as do not construct, because I really don't want to see them. They're just for building purposes there. And then this final one. It's do not construct for the in condition. The regular constrained component is always going to be there. And so now we've constructed it fixed 5 feet at the end, and then variable in the middle. We can test that again. And it's doing correctly. That last segment up there is staying a constant 5 feet. If we want to check that with a different slope, we can type in our slope here and say draw. So there, it seems to be working correctly. There is a case here when your surface gets within that initial 5 feet. I'm going to want a different in condition to solve. So I'm going to want a priority in condition probably for that first 5 feet in case I run across that case in my corridor. But after we get past that 5 feet, it is solving as we desired.